Hello, my name is Isabel Lara, and today I will be performing a spectrophotometry simulation. The purpose of this experiment is to determine the concentration of an unknown solution using spectrophotometry. We will create a calibration curve using known concentrations and use the measured absorbance of the unknown to calculate its concentration. In summary, for this experiment, I will begin by preparing a set of standard dilutions with known concentrations. Each dilution will be placed into a cuvette and inserted into the spectrophotometer, which will measure the absorbance of each solution, which I'll record. After collecting the absorbance values for all standard solutions, I will graph the absorbance versus concentration for each solution, forming a linear calibration curve, which is a graph used to determine the concentration of an unknown sample by comparing the unknown to a set of standard samples of known concentrations. Then, I will do the same with the unknown sample and place it into a cuvette and measure its absorbance with the spectrophotometer. Using our calibration line, I will match the unknown's absorbance to the corresponding concentration based on the line, which allows me to determine the concentration of the unknown. Throughout the experiment, I will explain step by step and at the end show how the data is analyzed and how the final concentration is obtained. We begin by preparing our samples. We will start with the stock blue 1 dye, which will be our darkest solution, meaning it will have the highest concentration. For the next tubes, we will start to dilute the stock blue dye with distilled water, which allows us to create a series of lighter solutions which will have lower concentration, which should result in lower absorbance according to Beer's law, which states that absorbance is directly proportional to concentration. Here we are preparing our samples. We can see the dilution shown at the bottom of the tubes. Our last tube will just consist of only distilled water labeled as blank here at the bottom. We will firstly insert our blank into the spectrophotometer and press 0 so the spectrophotometer will ignore any absorbance caused by the cuvette or solvent. Here we click 0. We will then rinse our cuvette using distilled water to clean, which we will do after each use, and then we will start to put the samples using pipettes. Here we are cleaning it. Then we will start with our samples. We will put each sample into the cuvette, like so, and then put the cuvette into the spectrophotometer. And then we will click measure to measure their absorbance to build our calibration line. Here we are cleaning it again. After each measurement, we clean our cuvette and repeat the same process. Measure, here we're cleaning it again. Measure. Measure. As you see, our measured T% values increase the lighter our solution is, meaning that the solutions with lower concentrations will have higher transmittance, which is the amount of light that is able to pass through the solution. If all the light gets through, that's 100%, and the percentage lowers if the amount of light that gets through is less. This means that the samples with higher measured T% values have lower absorbance. Here we are cleaning it for the last time, and then we're almost on our last sample, which is the blink. And the blink has 100% absorbance, which means all the light was able to get through. Here is our calibration line, which aligns with Beer's law that states absorbance is proportional to the path length through the sample and the concentration of the absorbing species. Here was our first sample, and then as you see with the lower colors, the absorbance lowered. Now we will repeat the same process we did with our other samples with our unknown sample. Here we are cleaning it. We place our sample into the cuvette and measure the absorbance, which was a 39%. As you see, there's a 39% transmittance, meaning that the unknown sample has high absorbance, which is 0.4089 as shown in our table. To find the concentration of the unknown sample, we divide the absorbance of the solution by the slope of our calibration line, which is right here, which equals to 0.4089 divided by 0.1358. Here's the absorbance, here's the slope, which gives us a concentration of 3.011 for our unknown, as shown here. This experiment shows how spectrophotometry can be used to find the concentration of an unknown solution by relating the absorbance of a solution to its concentration by using calibration.